Welcome back, Genghis. We are back once again. We were solving a problem yesterday. I think we figured it out. I was doing a mobile session yesterday, by the way, which is the most ideal way to do LeetCode, and it actually went pretty well. We pretty much stubbed out a basic version of the solution to the problem. I think it's just multiple binary searches. Hopefully that should work. There are some assumptions we have. Remains to be seen if those will pan out. Let me see if we have any comments today. If not, I think I'm just going to jump straight in. Don't think we have any. So, yeah, let's say we're going to jump right into it. Interestingly enough, I made the discovery. This is the problem we were working on. Didn't know this, but I actually tried this problem July 20, like months ago. July is the 7th month. 9 months ago. I don't know, something like that, but we couldn't solve it. And I think we should be able to solve this now. So since yesterday's version was on our phone, and I expected this to actually, I expected to be able to. I thought LeetCode would have cached it or something, but it looks like it just hasn't. So I think we're just gonna have to copy the code, which shouldn't be a lot. I have to copy the code from the function we wrote on our phones. That's what I'm gonna do real quick. We have function bsearch center. Pretty much the intuition behind this potential thing that we're working on is that we could use a binary search to figure out where the pivot is, or if there does exist. I wouldn't say a pivot, but where the broken center is, right? There's a node, or there's a point in the array where we go from where ascending order is broken. That is probably where the rotation began. If we can find that, we can split the array into two arrays sort of in ascending order, and then we can just do two binary searches on it. So I think that should work and allow us to keep time complexity of log n. So we had let pivot equals math.floor right minus left over 2 plus left. And then we had, if num sub pivot less than or equal to num sub pivot less than or equal to num sub pivot plus 1, and nums sub pivot greater than or equal to num sub pivot minus 1, right? That would mean we found the boundary, right? Because where we find that boundary, the pivot number, right, is going to be less than the next number. It's also going to be less than find it. So we'll test that actually. Num sub pivot minus 1 num check if the us less than left, right, and it should be less than right. Are we gonna actually make it less than or equal? Probably. Right would equal pivot minus 1. pretty much copy this. Change this to +1. Num sub pivot +1 is less than num sub pivot, which makes sense. Then num sub pivot +1 should be less than num sub, right? We'll allow equals 2. And then at the end, you can just return -1. Now we're just gonna return 0 because this is not correct. But if we do console.log research center for nums, it should be 1 value we're expecting. I think we had -1. STD out gives us 2, 0, 1. Definitely not it. Oh, it's distinct value, so we can actually remove the. Let me check that the code matches up. Pivot less than or equal to num sub pivot +1 and nums. And sub pivot greater than or equal to num sub pivot -1. Pivot else if pivot -1 is less than num left and right equals pivot minus. Oh. STD out 5 to print -1. Actually, though, I'm kind of confused why it's returning 1 index greater than the index looking for. The index with the boundaries actually index, if you look at the inserted numbers, 0, 1, 2, 3, 4. Except we return 5. And I'm pretty sure it might be because of this one right here. Let me just run this in my head real quick. We have 4, 5, 6, and 7. We calculate the midpoint. We get 0, 1, 2, 3, which is 7. We take a look at 7, because we have right, which is 7, minus left, which is equal to 0. 7 over 5 floor. 3 plus left, we get 0, 1, 2, 7. Is 7 less than or equal to num sub 0? No. Go to the next one. Is num sub minus 1, which is 6, less than 4? No. Num sub plus 1 is 0, less than 7? Yes. And is 0 less than, right? Yes. We do left equals pivot plus 1. Maybe we just literally need a line here. That equals 0. All right, so 0, 1, 2, 4. Right, then we do 7 minus 4, which for 2, 1.5 floor is 1. 4 plus 1 gives you 5. 0, 1, 2, 5, which is 1. Is 1 less than 2? Yes. And is 1 less than 0? No. Is 0 less than 1? Yes. And is 0 less than right? Yes. So right equals pivot minus 1. So now we have 5 and 6. Then we do 6 minus 5 is 1 over 2 is 0.5 floor to 0 plus left, which is 5. So now we're at 0. If num sub pivot 0 is less than pivot plus 1, yes, and num sub pivot is 0 less than or equal to 7, yes. So we should be returning not. So we have left Pivot equaling 3 makes no. This is before. Then we go to the next one. It is 5, 0, 1, 4, 5. Okay. 0 is not less than we just went down a rabbit hole. We could have just kept the original version we had. Num sub pivot. Num sub pivot minus 1 is less than num left. Problem is 5 is equal to 1. Left is equal to 0. So when they equal each other, now we actually get 4, which is the correct one without having to subtract 1. Okay, so I think we're pretty much done. I'll reset the test cases. Then we should just have to write a regular binary search. Except in this one, you can give us the left and right values to start with. While left less than right, pivot is equal to math.floor of right minus left over 2 plus left. Say if, oh, and we're actually looking for a target too. I will say if num sub pivot equals target, right, or return pivot. Else if num sub pivot less than target. So if num sub pivot is less than the target, then we can say left is equal to plus 1. Num sub pivot less than the target, it means every number before it is also less than the target. Else if num sub pivot greater than target, right, is equal to pivot minus 1. And if we couldn't find it, we'll return -1. And we'll say try, first try search, right, nums, with left being 0 and right being I don't know what a good variable name for this. Pretty much the first index, right? Call this first IDX. We can have a second try. That's in target, where first IDX will be where we start. nums dot length minus 1. Supposed to be in a and I think we're supposed to return the index. If first try greater than or row, return first try. Second try is greater than or equal to 0, return second try. Otherwise, we'll return negative. I'm confused. Why are we right? What time limit is exceeded? How? Doesn't quite make any sense. Oh, first index minus. What if I cancel out one of the B searches? Yeah, this is crazy. You still get. Time complexity, this would be 2 log of n. Which is basically drop the constants and it's log n. Oh, I think it might be. I think it's literally this one here. How is this time limit exceeded? This makes no sense. If nums.length equals 1, we return immediately. Oh, we still ended up running the code. That's my bad. we'll just stop there.